Peter Cahoon, and in this episode we're looking at stormwater drainage construction. With me is Dennis Woodbridge, retired RTA engineer. Now Dennis, we're talking about pipes, pox, culverts, drainage pits and all the associated foundation materials.
That's right, Peter. In this series we're going to be looking at some of the more important aspects of drainage construction.
Okay Dennis, let's get a general overview of what we're talking about one by one.
Well, firstly we need to understand that the manufacture and supply of components for stormwater drainage systems needs to be carefully monitored. Well, we have to understand also that it's important to manage the environmental impacts of drainage construction, so we need to understand the process of the installation of drainage but also managing the environmental impact.
Now a big heading is getting the foundations right, Dennis.
Yeah, foundations, Peter, are very important, and we encounter a whole range of difficult situations out there, and it's important that we understand what we need to do when we come across those.
Construction loads are a potential problem.
Yeah, Peter, it's easy to forget that sometimes during construction some of these pipe culverts and other structures are subjected to loads that are beyond their design capacity, and so we need to protect them temporarily.
So we're watching out for rollers and scrapers, I think I understand that. And last but by no means least, culvert design.
We always have to keep a focus on the fact that the life of drainage structures will normally be well in excess of the life of the pavement, and we're typically looking at 100 years. Now, you know, many drainage structures that were built in colonial times are still in service today.
Wow. Okay, Dennis, let's start with the last one, design.
Your Australian Standard 3725 basically talks about two types of culvert installation. That's trench installation and embankment installation. From
an architect's point of view, it's an imperfect process sometimes, design. I mean, you design for X and Y ends up on site.
Exactly. It's not uncommon, despite all our modern computer-aided design techniques, to find that when you get out on site, the level of the culverts as it's set out is, you know, a couple hundred mils below the natural surface, or maybe a couple hundred mils above the natural surface.
Yeah, and that'll require redesign.
Yeah, but either a redesign at the culvert inlet or outlet level, which may affect the hydraulic efficiency of the pipe, or a regrading of the natural surface at the outlet or the inlet, and that may have some environmental consequences. It has been known for drainage channels at the outlet of culverts to have sufficient grade only as far as the road reserve boundary, and then to have adverse grade thereafter. And this is the result of poor design or inadequate survey.
And this is even with modern computer-aided design.
Absolutely. Another problem that often occurs, particularly on urban projects, is that we find clashes between underground services, either planned or existing, and the stormwater pipes or pits.
So then it's a good idea to get the surveyors to mark out any new planned utilities and to pothole any existing utilities so any clashes can be noted.
Yeah, I think it's an absolute must, and any clashes can then be dealt with by a redesign of the utility level or location, or maybe the stormwater level or location.
What if we're extending an existing culvert? Now I understand this is quite common in urban projects. When you're widening a road or widening an embankment, you have to look at extending the existing culverts.
When the culvert has been extended in a straight line, then the existing headwall, or at least the wing walls, needs to be removed or demolished.
So we can get a clean join from the new extension to the existing culvert.
That's right. The end of the existing pipe should then be exposed for about 500 millimetres and neatly cut square. And the end of the new pipe section should then be butted up against the neatly sawn end of the old pipe and supported in place while a properly constructed concrete collar. Another option is to slot a section of larger pipe over the join and grout up the annulus between the two pipes.
So it's not just as simple as cutting the old pipe and slotting the new socket over it, because the new socket might necessarily fit the old pipe.
That's right. Then about 500 millimetres of the in situ backfill around the joint should be removed and replaced with a stabilised sand mix.
To really lock it in there, I think I've got you. Now that's for a straight pipe extension, but what if the new extension heads off at a different angle?
Well, if the extended pipe makes a bend at the joint, then what we need is a properly designed junction pit at the join. And ideally the junction pit should extend to the surface, to the natural surface, because we don't particularly like to see buried pits.
Okay, manufacturing. Now my understanding, Dennis, is the supply of quality drainage products to site can still be problematic. Well, here we are on site. Now you can design the most perfect round pipe you like, but when they arrive on site, Dennis, you've got to make sure they're all right. The quality can be sporadic.
The stuff that comes out of casting yards isn't always as good as we'd like it to be, and it's important that we do inspect it. It's important that the contractor or the supplier inspects it before they send it out, but it's not uncommon that pipes will get damaged in transit, even with the best will of all parties concerned. So it's important that the pipes are inspected when they're delivered to the site. Ideally, that's the contractor's responsibility, and his quality system should ensure for a visual inspection of the pipes, but we also have our own people, the surveillance officers, wandering around and looking at these things as well and doing visual inspections just to make sure that there aren't any serious cracks or spalls or major defects in the pipes and the pits.
Because we'll be getting rid of them.
If they're bad enough, we'll be sending them back, and how bad things have got to be is a matter of, I guess, judgment.
Specifically though, Dennis, when it comes to manufacturing, is there anything we need to know there?
Yeah, Peter, R11 has got a whole point where the contractor is supposed to submit to the RTA site management team a whole lot of documentation relating to the quality of the precast product being delivered to site, that is pipes and pits. So it's really important that the site team at least examine that information, but as we've said before, probably more than that, they also need to come out and do some visual inspections of their own.
Dennis, what if I'm inspecting a whole bunch of pipes and a lot of them are defect? What would I do? Can I organise an audit? What do I do?
We did have a situation where there's a lot of precast product being delivered to a site with a lot of defects being found. That's certainly one of the things that we would do. We would organise primarily for the contractor. We've suggested he organise an audit on the precast plant to make sure that they were following their quality processes and doing the right thing. And we may even organise an RTA team to do that audit as well.
Get the RTA team in.
Get the RTA team in.
Documents, Dennis. Now, I know it's important for the documents, particularly when we're talking about precast components.
Yeah, Peter, essentially the manufacture and supply of reinforced concrete pipes is governed by Australian Standard 4058, and the supply of fibre reinforced concrete pipes is covered by Australian Standard 4139. And on top of that, there's some other requirements spelled out in the RTA specification R11.
And box culverts?
Precast box culverts need to comply with RTA specification R16. Now, some of the larger box culverts are actually designed as bridges, and they need to comply with B80.
Now, one of the safety nets, I suppose, complying with all these specifications are hold points. Let's talk about those because they're important, hold points.
Yeah, Peter, R11 has got a hold point where the contractor has to provide a whole bunch of documentation related to the supply of precast products to the site. Now, it's really important that the RTA team at least check that and make sure that products do comply with the specification and the drawings.
Yeah, before we proceed.
Yeah, as I said out on site, it's essential for the contractor and also this RTA site management team to be inspecting pipes and pits as they're supplied to the site, but also importantly before they're actually installed.
So Dennis, is there anything else we need to be aware of at this point in the process?
Well, Peter, in the case of precast pits, they've been designed and certified by an engineer, and so any on-site modifications to them also need to be certified by an engineer. What we see sometimes is some contractors seem to think that they've got licence to go and cut holes in pits or even take out whole sections of those pits. And that significantly changes the structure and the way it resists loads.
The lesson there is they're certified for a reason. Don't go changing them without an engineer's certificate. Dennis, you and I both love getting out into the environs, as they say, to look at environmental practice, and that's exactly what we did. Now, one of the early issues to resolve is to work out where the natural water courses are coming off the landscape, and here they're coming through right down here where this water's pooling. And that's exactly, of course, Dennis, where we want to put the drainage system. So we need to divert nature so engineering can take over for a while.
Yep, that's right, Peter. In fact, this is quite a good example of a creek diversion. What we can see here is that they have diverted nature, as you put it, or they've diverted the creek around the site where we want to place the culvert, because we want to put the culvert where the creek was in the first place. And they've done a good job of it here because, as you can see, they've lined the whole channel with geotextile, and this is good environmental practice. What we have now is a situation where we're going to have clean water collected upstream of the culvert site, diverted through the culvert site in a geotextile lined channel, and it won't collect any sediment in the process of going from one side to the other. So it's good engineering practice, and it's also good environmental practice.
And once the transverse drainage is established and in and working, does this then become null and void?
Yeah, once the pipe culvert is installed and we can get the embankment constructed, then the water will be diverted back through the culvert and the diversion will be removed.
So this is where nature and the RTA come together as one. Now, I'd imagine by their nature, Dennis, that drainage lines are often located in existing creek beds. Now, what little knowledge I have about soil chemistry, do we ever have to worry about acid sulfate soils?
Well, acid sulfate soils are one of the things we could encounter. Others are what we call soft soils or even saturated soils, but yes, acid sulfate soils can be a problem.
Okay, so the very name suggests a problem, acid and sulfate. Are we talking sulfuric acids?
We are. Acid sulfate soils are the name given to the naturally occurring soils or sediments containing iron sulfides or the acidic products of the oxidation of those sulfides.
Right, yeah. Not for me, Dennis, but just for people watching, refresh us on the basic chemistry.
Well, Peter, when sulfides are exposed to air, oxidation takes place, and sulfuric acid is ultimately produced when the soil's capacity to neutralise the acidity is exceeded.
Not only an engineer, but a chemist as well. But the thing is here, it's the exposure to air which is the critical thing.
Yeah, as long as the sulfides soils remain under the water table, oxidation can't take place and the soils remain quite harmless and can remain there indefinitely.
But once oxidation occurs, bingo, that's when you get sulfuric acid. Now, managing acid sulfate soils is out of the scope of this episode, but good information can be found in the RTA guidelines managing acid sulfate soils. Now let's look at another early part of the process. There's the manufacture of the pipes and so on, but there's also the digging of the trench, the building of the foundations for the drainage lines.
Yes, and this is a critical part of the process.
Yeah, because we're dealing with varying site conditions.
Yeah, the contractor has to do the set out to match the details shown on the drawings for line and level. And at this point we have a whole point for the RTA site management team to inspect that set out. And it's really important that they do that because if it's wrong, this is the time to get it right.
Now, Dennis, something that we didn't see out on site because it wasn't an issue there was settlement. What do we need to consider there?
A good question. Where embankments are constructed over soft soils, the control of settlement of pipelines is critical, and it's essential that the design assumptions are shown on the drawings and that they are fully complied with.
And that would include things like the support of the pipes.
Yes, and the alternatives for pipe support include things like rock mattresses, or timber and other types of piles.
So it's clearly not a case of just shoving in whatever's at hand. You really need to design these foundations properly. And obviously, Dennis, all these methods have to be approved.
They do, Peter, and various practices have evolved over time to handle thick layers of soft or wet materials under culverts. But rather than go into detail here, there is an RTA technical direction which sets out a range of suitable treatments depending on the situation you're faced with.
Well, I was looking forward to hearing a little bit more about rock mattresses, but I suppose all of this bedding comes immediately before the laying of the pipes, right? So we're at the point where the drainage system is marked out, the pipes and box culverts have been manufactured, the excavation has been done. We're at another hold point, Dennis?
Well, what we actually have is called a witness point, and it's an opportunity when the foundations have been exposed for either embankment or trench construction, and this is an opportunity for the RTA site management team to inspect those foundations and agree that they're acceptable.
Okay.
And we also have the whole point that you were mentioning, which is an opportunity for the contractor to identify and propose the removal of any inadequate foundation material.
Now, to the untrained eye, this just looks like a normal ditch, a trench, but Dennis, there's more to it. You've picked up something here.
What we're looking at here, Peter, is the foundation excavation for an embankment construction pipe culvert, and this is the upstream end we're looking at. And what you can see here is, see this black gooey looking stuff?
Yep.
That's alluvium, it's highly wet, saturated, it's pretty much rubbish material, and obviously that would not be suitable for foundation of a culvert.
Right.
But what you can notice here is there's an interface between the black gooey stuff and then you get into a more grey coloured material.
Yeah.
And if you look down the bottom of the foundation now, you can see it's actually quite a stiff clay.
Yep.
And that's suitable for foundation material.
Right. So we need to cut down below the no good stuff into the good stuff before.
Yeah. In this case, we're lucky because when they've got down to the level they wanted to get at, the material is in fact okay.
Yeah.
But if it had been still of that black gooey nature,
yeah,
then we would have had to have gone down further till we'd removed all that and replaced it with good material. It is the RTA site management team's responsibility to confirm and direct the extent of the removal of what we call inadequate foundation material. And this can include not only the bottom of trenches, but also the sides of trenches.
You use the word inadequate there. Now, this is not to be confused with the word unsuitable, which is used in earthworks construction. It all sounds a little bit complicated, but is there a physical difference between the word unsuitable and inadequate, or is it a situational difference?
It really is just a situational difference. There's a pay item in R11 for the removal and replacement of inadequate foundation material in the floors of trenches. There's a similar pay item under R44, the RTA's earthwork specification, for the removal and replacement of unsuitable material under embankments or in the floors of cuttings. And we just don't want to confuse the two situations, so we use different terms.
Yeah, not confusing at all, Dennis.
Well, having said that, I think there is room for confusion when we're talking about removing and replacing significant quantities of poor quality material from, say, a stream bed, where we intend later to install a culvert and an embankment. Which pay item is relevant then?
Okay, glad we cleared that up.
Before moving on from inadequate material, it's important to have thought through where the material will come from to replace the inadequate material. Will it come from elsewhere on the site, or will it be imported? Now, the expectation or the assumption of R11 is that it will come from elsewhere on the site, but this may not always be possible.
And that brings us rather neatly onto backfilling. Dennis, a number of different stockpiles here. What's this one?
This particular one, Peter, is the stockpile of bedding material and haunch material. So the specification requires us to have a stone size less than 19 millimetres and a plastic index less than 6. And this material would well and truly comply with that requirement.
We're at the Bulahdelah bypass on the mid-north coast, and Dennis, this is a great example of transverse drainage.
Yeah, Peter, this is a very good example of transverse drainage, and what we've got here is pretty soft and gooey sort of material, which they've previously excavated. So we've got here at the stage where they've already done the excavation for the foundation. We've been told there's been some inadequate material here that's been previously excavated and replaced with good quality material. Then they put the foundation down, and then they put the pipes in, laying the pipes from the downstream side to the upstream side, which is the sort of practice that we recommend. And following that, they've now placed, they're at the stage now where they're placing the side zone material.
There are all sorts of markings on the pipes, aren't there, Dennis, to describe exactly who they are and where they're supposed to go?
Yeah, these markings here, Peter, there's a few here. There's a manufacturer's name. The top one is the weight of the pipe, which in this case is 2,500 kilograms, and that's just important from lifting point of view.
Yep.
The most important ones are the pipe diameter here. This is a 1,050 millimetre diameter pipe.
That's internally, right?
That's internally.
Yep.
And then you've got a class of pipe, and this is a class 4 pipe. Probably the most important thing to note here is that it's important, obviously, to make sure that you put the right class of pipe in the right situation. Yeah, so these things need to be checked and checked again. Bedding and backfill need to be placed and compacted in layers not exceeding 150 millimetres, because we can generally only use small compaction equipment. And it's important that we do achieve this high standard of compaction, which in the case of the RTA is somewhere between 95 and 100% relative compaction, depending on the zone and the type of culvert we're talking about.
And Dennis, I noticed you said there for the RTA. Does that mean the RTA have higher than normal standards?
Yes, Peter, the RTA standards for compaction are in fact higher than those required by the Australian standard, and also our requirements for the material properties of the backfill are also stricter.
So for RTA projects, it's no good just complying with the Australian standard. You have to raise your game and comply with the RTA compaction standards set out in R11.
And that's why the testing frequency for things like grading and plasticity index and compaction are relatively high as well.
What else do we need to look out for at this stage? We've got our pipes, they've been checked, they comply with the drawings. What now?
If all the pipes are to specification, undamaged and designed,
there's no breaks or cracks,
then we put down the bedding and lay the pipes.
Now, it's not a case of lying a whole trench of bedding then laying all the pipes. The bedding goes down just ahead of the pipe laying.
That's right. The bedding is critical to the functionality of the whole culvert and provides a uniform support to the pipes. The load carrying capacity of the whole thing depends on the uniform support provided by that bedding. That's why we've seen they take a great deal of care in making it even and level, and even to the extent of, as we've seen, providing a little slot for the socket.
And Dennis, the socket is placed uphill. I'd imagine that's to minimise slipping. Now, I'd imagine that alignment and grade are critical things in this part of the process.
Absolutely, and what's important here is that the foundation is not compromised simply to achieve the grade.
So there's no shortcuts like lifting one end or packing out the bedding to get the alignment right. You need to really take care here. Okay, so your bedding needs to be installed, followed by your pipes, and then careful attention needs to be paid to the jointing of the pipes as they're installed. Moving on, let's talk about head walls.
At both ends of pipe culverts we have head walls, and they are an important part of the structure. And an important part of the head wall is what we call the cut-off wall. And that is designed specifically to prevent what we call piping, which can be a cause of pipeline failures.
Now piping, isn't this what all these pipes are for? But I can tell by Dennis's voice there's more to it.
The piping in the sense that I'm talking about it is when water runs outside the pipe itself in through the bedding.
Okay, so that's where the head wall comes in to prevent this.
Yes, and for good practice, a head wall should definitely have a cut-off wall.
Designed for what? To channel or funnel the water back into the pipe?
The combination of the head wall and the cut-off wall is designed to channel the water into the pipe itself. But if the cut-off wall isn't deep enough, or even if it doesn't exist, we can have the situation where the water can find its way underneath the head wall and into the foundation or the backfill material and cause this problem that we call piping.
That's not good.
It isn't good, Peter, and also head walls on the outlets of the pipes without cut-off walls are also prone to undermining, and that can lead to expensive repairs.
And as we saw on location, head walls come in all shapes and sizes. The head wall can be cast in situ, which is what we have here, Dennis.
That's exactly right, Peter. What we have here, as you said, is a cast in situ head wall from a precast box culvert with a very large apron, and as you can see here, the cut-off wall extends for quite some distance below the apron level.
But I suppose the important point here is by turning this wall down, it helps prevent water seeping back from nature, eroding all the foundations of the culvert.
Yeah, that's right, Peter. This is a little bit deceptive here because the finished surface level of the stream bed is going to be up here at this level. So this area is all going to be backfilled later with boulders and other material to bring the stream bed up to this level. But you can see that the cut-off wall is quite deep, and its primary purpose is to prevent water seeping in underneath the apron and eroding away the foundations.
Well, eroding away the foundations, and I imagine nobody wants that. I'd imagine there's other problems here for undermining and piping, and from where I stand, I imagine if the pipes aren't connected together, I mean, that's going to be a problem as well.
That's right, Peter. In practice, piping is also caused by pipes coming apart and box culvert units coming apart underneath the embankment. In practice, we make these joints with rubber O-rings. If they aren't installed properly during construction, they can leak later on, and that can cause leakage of water from the pipe into the bedding and also then lead to this piping problem again. It's important installing the O-ring to make sure that it's uniformly placed around the spigot before the spigot is then pushed in gently and uniformly so that we get a good watertight seal.
Have a look at this, Peter. We're just on our way to the trench, but I thought I'd show you this. This is what we call an O-ring, and you can see some just sitting there.
Have a look at this, folks, an O-ring in the wild.
That's right. So basically, we're looking at the spigot end of the pipe.
Right.
And the socket end, where it flares out, is your socket end.
Socket end.
That's right.
That's the spigot end.
So the O-ring is installed on the spigot end.
Yep.
And basically what that does, it makes it watertight. So no water can get through the socket and into the pipe.
And that's all you need, just the big O.
That's right, but you've got to install it properly.
Right.
Sometimes this slips off that way and water can get in. Other times it comes on here like that.
Yeah,
After a while it just comes off.
That's no good.
So you've got to make sure that that's inserted properly.
So all you need to keep it waterproof is the big O, put on properly.
That's right.
Thanks for pointing that out, Roy. So that's something to watch out for during construction. Every pipe needs to be mated properly with its neighbour.
Also, of course, any pipes with cracked or broken spigots or sockets need to be rejected before they're installed.
But I noticed when we were out on site, the workforce took a lot of attention to the weather.
Absolutely. Weather is one of the things we worry about a lot, and it's important that each individual element of drainage construction is completed in the shortest practicable time. But having said that, the quality of the work should not be jeopardised as a result of trying to get it done quickly.
Yeah, don't rush it.
Don't rush it.
And Dennis, we're not just talking about pipes and box culverts.
No, it's about all aspects of including temporary head walls and associated pits and of course even open drains, because we want to minimise the project's exposure to adverse weather conditions and adverse environmental outcomes such as erosion or sediment runoff in the event when we get heavy rainfall. Well, I think what we saw out on site earlier is a good example of how to minimise those risks.
And what we see here are some pictures of what can go wrong.
Incomplete drainage systems like we've seen on these photos substantially increase the risk of unacceptable erosion and sedimentation outcomes.
Okay, but the reality is on projects you're going to experience bad weather. Dennis, is there anything we can do to minimise the damage?
Well, one thing we should do is to ensure that the drainage is installed uphill, that is from the outlet of the culvert to the inlet of the culvert, in order to minimise the risk of damage, and that's what we saw out on site.
These jumping jack compactors, they're cute, aren't they? But they seem rather small for this huge site.
Yeah, they do seem a bit small, but we do use these small equipment type whacker packers to compact around pipes, because the main aim of the game is not to damage the pipe. And if we were to use big equipment like big rollers, there's a real risk of the pipe being damaged until the point in time when we get enough material over the top of the pipe that we can use bigger equipment.
Makes sense. And what we saw there, and an important thing, is we're compacting the fill and not the pipe.
And that's an important distinction. And that's why we use small compactors, and it's not until we get a decent layer of fill material over the top of the pipe that we can begin to use heavier compaction equipment. We did just see some heavy construction equipment crossing a partially completed pipe culvert. The same principles apply to box culverts.
That's right. Well, Brett's one of the site engineers here at the Oxley Highway, just west of Port Macquarie. Now, Brett, we've got some transverse drainage under the road here, but this culvert needs to be protected because there's more work going on.
That's right, Peter. The box culvert hasn't been designed to take the loads of the heavy construction plant. So in accordance with R11, the contractor's gone away and done some calculations to work out how much fill needs to be placed here to protect the structure. So we've got 300 mils of select gravel and then an additional 500 mils of general fill to give us 800 mils of protection.
It's interesting, isn't it? Because already the top of the culvert is 250 thick of concrete, but it's still not enough to protect it.
That's correct.
And here comes one of the big fellas now, and as it goes across the top of this box culvert, the load will come across there and it's transversed across the culvert so the point load won't crack it. But now that the drainage line is in, our job's not finished yet.
Almost, but not quite. On completion of the construction of the drainage lines, but before we actually put the pavement in place, the contractor is required to undertake a CCTV inspection of all the pipes. That involves putting a camera down the pipes to make sure that there's no damage, there's no leakages, there's no material in the pipes that's been deposited that shouldn't be there.
I have to say, Dennis, it's a complex journey, isn't it? From the first excavation to ending up with a functioning drainage system. But I suppose the message is here, at every step along the way, there's going to be room for error.
Yes, Peter, and any error can have serious consequences in terms of environmental outcomes or in terms of long-term durability.
I know we shouldn't target one area because they're all critical, but from an outsider's point of view, I'd imagine that the foundations, the bedding, is really critical to get right.
Yeah, and in practice, a lot of problems stem from there. But having said that, we need vigilance at every step.
Thank you, Dennis, because when we measure the life of these systems, we're not talking decades, we're talking centuries.